Good afternoon. We are going to do 4.6, congruence in overlapping triangles. And I think one of the main strategies that we want to focus on here today is how do we take a drawing that looks really confusing and turn it into something that we can analyze and look at for triangle congruence. So we will be doing quite a bit of drawing. Make sure you have a ruler. We will be using a highlighter or two, so if you have those or colored ink, it's going to come in handy. Okay, example 1, our triangles FHJ and KHG congruent and Y. So one thing you can do is use a highlighter. FHJ is this triangle here. And then the other triangle is KHG, which is this triangle here. So sometimes just highlighting the triangles works well enough to tell them apart. Another method that works really well is just redrawing them. So draw the one on the left. Try to keep it oriented as much like the original as possible. And then we have the other one. It looks something like this. So we have H, F, and J. And then this one is H, G, and K. By drawing them individually, you now have a way to transfer the information. Like angle F is congruent to angle K. I can transfer that. Now here's where this one gets interesting. F to J is a combination of double tick mark plus 1. G to K is also a combination of double tick mark plus 1. And what we get by drawing it out is 2 tick marks plus 1 has to equal 2 tick marks plus 1. That would be segment addition postulate. So we can say that these two sides are congruent. So then the last thing we're looking for is we need a third piece of information. Well, both of these triangles obviously share vertex H. So angle H and angle H are congruent because of reflexive property. Now we have an angle, and a non-included side. So the answer is yes, they are congruent. So you can highlight or you can draw separate. Both work well. Okay, let's do a few more of these. Tell which triangles you can show are congruent in order to prove the statement. What postulate or theorem would you use? So basically they want us to prove congruence so that by CPCTC we can get the body parts they want us to get. Okay, so looking at this one, we have a single side and a double side, and look, a shared side. So 3 sides in common, that would be side, side, side congruence postulate. And because we know that, CPCTC, angles A and D are congruent. Let's look at number 4. You have a couple sides that are congruent. We can't do side, side, side because we don't know the third sides, but we do know that vertical angles are congruent, so those two angles are congruent with each other. Vertical angles are congruent, and then that gives us side, angle, side, which will prove congruence and give us what they want, which is Q, angles Q and angle T. All right, let's look at the third one, or at number 5. All right, so if this is 90, that is 90 because a straight angle equals 180. So if the right is 90, the left is 90. Both triangles also share KM. That is reflexive property. So I've got a hypotenuse and I have a leg. The question is it enough? Well, they are right triangles, so that allows us to use the shortcut, which is hypotenuse leg theorem, because we do have 2 right triangles to work with. Okay, let's get a little more complicated. Number 6. We're looking for congruency. Well, this triangle and this triangle both share AD, so that's reflexive property. And then let's see if these angles can give us something. I've got 2 parallel lines cut by a transversal. So alternate interior angles are congruent. So now I have an angle, and a non-included side. So yes, those are congruent. Angle, non-congruent side. Non-included side, excuse me. All right, this is one where you've got the overlapping triangle issue. So again, it might be easiest if you redraw the triangles separately and put the markings on them in a way that you can see clearly. So I have short side and short side. Those are marked. G is marked as congruent to H. And then I've got N and L. So I have an angle, and a non-included side. Angle, side. See how drawing those out? Sorry, there we go. See how drawing those out made a big difference in how we looked at the triangles? Sometimes that's all it takes, is just to redraw what you've got. Here's another example where you've got overlapping triangles. You might want to redraw because you've got one that's sort of sticking out at this angle, and then you've got another one that's upside down. And by separating them, we can mark them. So Q and T are congruent. I have a double hatch on RT and a double hatch on UW. And, aha, look at this. I have this angle and this angle are the same in that triangle. And in the second triangle, Q and W are also the same. So I've got an angle, and a non-included side. That's another angle, side. So again, don't be afraid to draw those out and see them separately. All right, flip the page. We're going to go over a proof. This is a little bit more complex proof than what we've done. We are going to go step by step though, and I've given you a nice big box to do your drawing in. We're supposed to prove that triangle SRV, which is this one right here, SRV is congruent to TUW, which is that triangle. Okay. So again, this might be one where drawing out the triangles separately will help our brain see the differences. So I've got one facing that direction. I've got one facing that direction. All right, so this is S and R. I have a triangle and a mark. That's V. And then this one I have T and U that have a right angle marked and a single tick mark. And this is W. Okay, so we're trying to prove that the triangles are congruent to each other. So we can prove that these are right triangles. So we can, if we prove that they're right triangles, that means we can get away with hypotenuse leg. But we have to come up with a way to find that third side. And that third side, the bottom ones, there's really no telling them apart. They're overlapped. I don't know any measurements, so this bottom edge is probably a lost cause. But if I look at their top edge, this pink top edge is actually part of a triangle that has ST at the top, and then down to W, and then over. Can you see how this side is a part of this triangle right here? The SWT triangle. And we can do the same thing with the other one. S and T, and then we have a triangle that comes down to V and then shoots over. And maybe if we can get the shared side, the WT and the VS, that will give us WT and VS for our top one. But let's do the top to begin with. Okay, so statements and reasons. First, we're going to list what they show us in the drawing. They show us in the drawing that segment SR is congruent to TU, and that's given in the drawing. They tell us that R and U, angle R and angle U, are right angles. That's what the boxes mean. That's given in the drawing. Okay, so because both triangles have right angles, it means they are right triangles. So triangle RSV and triangle UTW are, and we're actually not going to use this fourth step, I moved it down. They are right triangles. Remember, we're trying to get set up for hypotenuse leg, so we need to have right triangles. That would be the definition of right triangles, which of course is that they have a right angle. Okay, so we've got that far. Now again, our overlap sides that we're interested in are WT and SV. You have top triangles, you have bottom triangles. So now we're going to look at these two. And we have some markings on these. Angle T, in the drawing, angle T has a mark, angle S has a mark. So this angle and this angle are marked the same. ST obviously has to be congruent to itself. So ST and ST are congruent. That's pretty straightforward. And then if you look at the drawing, W and V are marked congruent. So this one and this one are marked congruent. And again, the drawing has these two marked congruent like that, and then it has these little corner angles. So just from that information from the drawing, I've got angle, angle, and a non-included side. I've got triangle congruence. Once I get triangle congruence, I get the body parts I want, which are these overlap sides. So let's list out what we discovered. Let's start with the single tick mark. Angle STW is congruent with angle TSV, and that's given in the drawing. And then they tell us that W and V, but we have to label them more specific. Angle SWT is congruent to angle TVS. This is our double hatches given in the drawing. We know that ST is congruent to ST because of reflexive property. More specifically, reflexive property of congruence. Okay, so now we've got our triangles here. We have triangle SWT is congruent to triangle TVS because of angle, angle, side congruence. Aha! Now we can say that these two overlap sides are congruent. I can say WT is congruent to VS because corresponding parts of congruent triangles are congruent. So now that I have these congruent, I can go back up to my other drawing. I have these two congruent. Now I have hypotenuse and a leg. So now I can say what I'm trying to prove, triangle SRV is congruent to triangle TUW because of hypotenuse leg theorem. So if I had to go over a strategy with you, it was, okay, we knew we had two right triangles, and we guessed maybe hypotenuse leg would work. So we proved they were right triangles and what the sides were for the ones we wanted. Then, to get the sides that we needed, we had to switch our view to this triangle and this triangle, the upside down triangles. those also had their own markings. So we stated the givens, we said reflexive property, and by proving these two congruent, we got the overlap side, which was WT and SV, which then on our home drawing, WT and SV gave us the hypotenuse that we needed. So sometimes you're going to go and get triangles that are different than the ones you're trying to prove so that you can get body parts you wouldn't be able to get any other way. All right, that is it. Have a good afternoon.